Alright, what about, let's do number 3. Negative 9 times what is negative 72? Yes.
32.
Did you say 8?
Yes.
Very good. And so negative 72 divided by negative 9 is 8. I almost made that negative. That's better. Alright, then number 4. Negative 7 times what is 56? Yes.
Negative 8.
Bam. Why does this have to be negative, you guys? Yes.
Negative.
There you go. Then 56 divided by negative 7 would, again, be negative 8. So something times negative 3 is 15. What do you guys got? Yes.
Negative 5.
Bam, negative 5. So this one has 2 blanks, though. 15 divided by what equals what? Now, it should be related to what the problem we just did. So that it creates a fact family. Yeah, what do you got?
Wouldn't the first one be either negative 5 or negative 3?
All right. Does it matter?
No.
So which one do you guys want it to be?
Negative 3.
Negative 3? Well, if we make that one negative 3, then 15 divided by negative 3 would equal? Negative 5, right? There we go. All right. Good luck.
Wait, okay, there's 6. Something times 4 equals negative 48. So, first I'm just going to take out this negative. So, out of negative 48, I'm going to take out the negative for a second, and I'll put it back soon. And I'm going to find out what 4 times what equals 48. So I can't exactly show my work on here, other than that 48. So what I'm going to do is I am going to take the 4 and 48 and divide it in my head, and that would equal 12. So and then if we put that negative back, then 12 would. That means it would have to be negative 12 since you have to have an odd to get negative. And then right here, 48 divided by what equals what? Negative 48 divided by what equals what? So basically it would be negative 12 or 4, whatever you want. I'm gonna do negative 12. And it will equal 4, or you could do 4 and it will equal negative 12.
Very good. Excellent. All right, good luck. Would you mind explaining, please?
9 times 4 is 36, or you divide 36 by 9 and that's 4, and then you just put 36 divided by 9 because that's how you get 4.
All right. Very good. Good luck.
So basically, since this equals a positive number, you have to have 2 negatives. So this would have to be a negative. So, and 88 divided by 8 would equal 11, so it would have to be negative 11, because 11 times 8 is 88. And for this one, you could just do 11, and it would be 8. Because 88 divided by 11 equals 8.
Okay. Thank you. All right, now for this to be fully related, we got to use the same signs on all the numbers. So since that was a negative 11, we'll just make that negative 11 there. And then the 8 was also negative, so we'll just keep it negative there. It still works. Alright, so there's something else we should notice on this. So these are the products. That's the answer to a multiplication problem. Where do they all appear in all of these ones? Yes?
The beginning of the
Very good. Yeah, it's the beginning or the first number there. Alright. Now, it's not necessary that you guys know this, but the product for a multiplication problem, this first number that's being divided is called the dividend. And so the product always becomes the dividend in a fact family. Yeah, so you guys have done them. And like some of you guys mentioned, we could change these second two numbers out or switch them out amongst each other. It all depends on which fact in the fact family you're looking for. All right, let's go ahead and answer number 9, 10, 11, and 12. Try to write a related multiplication problem for these, and then we'll find the answer for them. Alright, so I'll do 9 for you guys, just help you guys get started. So if I wanted a fact family for this one, I know that the product is going to be the first number in my multiplication, so I got the first number multiplied by the second number, and that should equal that third number, right? Wait, I think I may have said that wrong, so I was thinking of that backwards. So in other words, we're looking for the quotient here, not the product. So in the multiplication problem, where would you guys put the 12? Yes? Someone? No? Yes? Very good. That is excellent. Because in the division problem, the product is always that first number, or the dividend. Well, then where does the negative 3 go? Where? Yeah, wherever you want. So where do you guys want it? In the front? Alright, let's put it in the front. So negative 3 times what is 12? So I like the reasoning here. Since we got the negative there in the front and our answer is positive, we know we're going to need another negative there. And so now we're just looking for 3 times what is 12? Yes? Adrian, right? What? Bam, there you go. Negative 3 times negative 4, so that would be the answer to the division problem there. If I hadn't already explained that, a quotient is the answer to a division problem. Good luck.
Quick. Okay. So the answer would be 4 for that, and then you would, for the fact family, it'd be, no, negative 4, sorry. Times negative 10. Yeah.
And that would equal?
40.
Yeah, go and write that in. Very good. All right, thank you.
Yeah.
Thank you.
Okay, so with this one, since it has 2 negatives, you just divide 8 by 2, which is 4, and since it has 2 negatives, it would cancel each other out and be 4. So not negative 4, but 4. And the problem would be 4 times negative 2 equals negative 8 because it has 1 negative. So yeah.
That's very good. Thank you. Thank you.
So you divide negative 96 divided by negative 12 and you get 8, so you times negative 12 times 8 and you get negative 96.
Alright, very nice. Thank you. In the number line school, there's one straight hallway, which is rather convenient for a number line school. The numbers on the classrooms indicate the distance from the main office, which is at 0. We don't know if that's in foots or yards or miles. It didn't tell us, so we're just going to say units. Mark the location of the following classrooms on the map of number line school below. So it tells us the names of some of the teachers. Let's start with old Mr. Bowen, rather. Good old Mr. Bowen. So Mr. Bowen is at negative 3 1/4, alright? So negative 3, as we can see, is right here. But this is negative 3 and some, so since we're going in the negative direction, we need to go further. Negative 3 1/4, about yonder, okay? Now it is difficult to tell exactly where a quarter is, or negative 3 1/4, because the number line is so small, and it's not marked in between. So, right there would be good. Here's what would not be good. Let's say that you thought that negative 3 1/4, bam, right there. See, now you're on the wrong side of negative 3. No good. So what do? Maybe we put it right here. See, now you're too close to negative 4. It's unfortunate. You'll get points marked off if you do that. Negative 3 1/4, bam. Some people are going to put it right there. Now you're on the wrong side of the school. You're going to be late to class, right? So the reason I point this out is because sometimes students are like, oh, there's 3 1/4 right there. All right, you're close, but you're not really close. You see what I'm saying? And that is right here. That was a little bit to the right there. That's better. Good. And this person is Mr. Bowen. I'm just going to put a B for Bowen because none of the other teachers' names starts with B. That makes it extremely convenient. All right. Also, I put his name in black right here. So, next up, Miss England. Right here. Miss England is at negative 6 1/4. Bam, right here. And once again, I will label these England. All right. Now we got Mr. Franks. Yeah, Franks. I think it's French, right? Like Francais or Franck. Well, Mr. Franck. Yeah, Franck, right? Negative 8 1/3. Negative 8 1/3, I'm going to put right yonder. Now, some of you guys look at that and think to yourself, that is so close to negative 8 1/4. Well, that's because of the number line. Okay, we already talked about how they're so close together. It's hard to tell where the difference between 1/3 and 1/4 is on this type of number line. Now let's go ahead and label this up in here. Franck. So far, so good. Now let's go to Ms. Abe, who was at 3 1/2. Bam, nailed it. Right there. Okay. Let's label this, bless you, Abe. Moving on, Chidester. Chidester 5.25 or 5 1/4. Bam, I got it right here. And then we just need a label. A little Chidester. Now I'm going to go back because I'm running out of colors here. We're going to put in Mr. David at negative 5.2. Bam. Got it. And this is David, so we're going to put a D right here. Now we got to look whose classroom is further, and this is from the office, the main office, which is there at 0, because it says right there at 0 that it's main. And it gives us, this is multiple choice. Let's look at old Ms. Abe, who is 3 1/2 away from the main office. And then Chidester, who is, where's Chidester? 5.25 away. So Whose classroom is farther away? Chitster. Bam, there we go. Next question. Approximately how far is Miss Abe and Miss Chitster? How far apart are they? They're about 2 apart. That's just a nice estimation. We know that because if you look at A, and you went 1 unit, that'd be 4.5, and then another unit, 5.5. That's about how far apart they are. Now we want to know exactly how far apart they is. Well, let's look at old Chitster up in here. Chitster is 5.25, and how do we find distance between two numbers? What operation? Subtraction. So we're going to subtract from 5.25 Abe, who is at 3.5, and we're going to need a 0 up in here, maybe, to help us see. 5 minus 0, 5. 2 minus 5, 7. How? Because I borrowed 1 from the 5, so I made it 12. 4 minus 3, 1. Bam. 1.75 units. That's how far apart they is. Joe has Mr. Bowen's class first hour. Well, here's Mr. Bowen. Mr. Bowen is at negative 3 1/4, right here from the main. And then Miss England's class second hour. So from here, he's going to go over here to Miss England's class. How far apart are these two classes? Well, England is at negative 6 1/4. So taking off the quarter, we can kind of ignore those because we're still in the negatives. How far apart are negative 6 1/4 and negative 3 1/4? That would be exactly 3 units. What is the distance between, let's look, we got Chitster, who is at 5, oh, that's a 5, there we go, 5.25, and Mr. Dabids, who is at, where is old David, negative 5.2, right here, right? So how do we find the distance between these two? Bam, subtract. We're going to subtract that negative 5.2, which means we're going to change this to big fat addition sign. So now I got 5.25 plus 5.2, which gives me 10.45. And we'll just say units. Bam. 10.45 units away from each other. Notice it did tell us to estimate. No, we will not be estimating because estimation is lame, especially when we're going to solve for the exact distance anyways. What is the distance between Frank, who is right here, at negative 8 1/3, and Miss English? Yeah. How far apart are they? Well, Frank is negative 8 1/3. Oh, we better show this one. Alright, so yes, we are subtracting because we're finding the distance between these two. And what do we get up in here? Well, I don't know how they do this in elementary or how they taught this to you guys, but here's how we're going to do it in 7th grade. We're going to change these, which are called mixed numbers, into improper fractions. Very good. What is an improper fraction? Where the numerator is bigger than the denominator. So a proper fraction is where the numerator is smaller than the denominator, okay? So first off, before we do that, I'm going to change this to a big fat plus sign so that we can see that the opposite of minus is plus. And then we got negative 6 1/4. So how do we change the negative 6 1/4 to a mixed number?
4 times 2.
Yeah, we got to do 6 times 4. We will keep the 4 in the denominator, but what's 6 times 4? 24. Now what?
25 plus 1.
Plus the 1, that gives us 25/4. And we need to keep the negative up in here. Of course, from this thing, we're going to add 8 1/3. So, we're going to do the same thing, use the same method. What's 8 times 3? 24. Plus the 1? 25. Bam. 25/3, because we keep the denominator. Now, here's kind of why that works, is because right up in here, it was telling us that we had 8 kind of like full pans of cake, and then we had a third of a cake. So we had 8 cakes and a third. That's why we multiply the 8 by 3. Because it tells us how many thirds the 8 is, which would be 24 thirds. Alright, well we need to add these, right? Bam, let's go ahead, do it. 25 plus 25. Well, we would treat that as a negative 25 actually. Plus 25, 0. 4 plus 3, 7. 0. Nailed it. Yeah, that was great, right? Wrong. That is not how we add or subtract fractions. What do we need before we add or subtract fractions? Yes?
Make the denominators the same.
Yeah, we need the denominators to be exactly the same. So, yeah, we can use the denominator of 12. So, how do we make the denominator 12, though? Times what by 3? 4. See, 3 times 4 is 12. This will still be negative. But if we do it to the denominator, we got to do it to the numerator as well. 75. Now let's go ahead and add this. We need to do the same thing to the 25 thirds. Times 4 and times 4. That gives us 100 twelfths. Something you guys need to notice is that 25 fourths is the same exact value as 75 twelfths. And 25 thirds has the same value as 100 twelfths. All we did is we scaled the numbers up to have the same denominators, but the value has not changed. So, we're going to add the same parts together. Okay, the 12 is in the denominator for both of these. It's telling us how big the pieces are. And now that we have the same size pieces, we can just add the numerator. So, I'm going to change this. We still have a denominator of 12, but I got a negative 75 plus 100. And what does that equals? 25 over 12. So in elementary, your teachers told you, well, if you keep it like that, it's wrong. Why? Because we have to simplify, right?
Yeah.
Well, in 7th grade, we are done. Yeah. And that's great. No, yeah. In 7th grade, we don't really care for mixed numbers because, as you can see, we change mixed numbers a lot into improper fractions, so we can just keep it that way. So that's that'll do. And yeah, we should label this units. All right, let's look at this addition and subtraction of fraction stuff. All right, so you guys give me a fraction.
35.
35 is not a fraction. No, that's lame. Give me a different one. Give me.
1.5.
Yeah, nice. Let's try 1/2. That's a good one.
Yay.
And maybe a third, right?
No.
Let's go ahead and add these two together because, well, addition is less confusing. 1/2 plus a third. So when we were young and didn't know anything about math, we would say 1 plus 1 is 2 and 2 plus 3 is 5. And you'd say, yeah, you'd have 2/5, right?
Sure.
And then someone laughed at you and you felt bad, so you said, and they told you it was wrong. But they didn't really tell you why it was wrong, okay? This is why that is wrong, all right? Let us consider something that we like a rectangle. A rectangle full of cake. Let's, now, well, this first one tells us that we got half a cake. What kind of cake do you guys want this to be? Ice cream cake, chocolate ice cream, or vanilla? Mint chocolate chip? Yeah.
Cookies and cream.
Alright, you know what? I'm just going to make this a chocolate cake. I like my chocolate cake.
Me too.
In this chocolate cake will be chocolate chips, not shapes. Whatever the heck that is. But we've got a nice chocolate chip cake. You guys want frosting on that thing?
Yeah.
Frosting, what frosting?
Chocolate.
And it has that molten chocolate stuff inside as well. Super chocolatey. No, we're not finished yet. So, let's take this half a cake. And then up in here, we got another pan, a rectangle pan, that is full of a third of a cake. So we're just going to split this up just so we can see the third parts. And yes, we've got the third. So your mom comes to you and she says, we need to combine the cakes into one pan so we can conserve fridge space, right? And you say, well, I'll just eat it, Ma. And then she slaps you in the face and she says, no, you will not eat it. I just want them in the same pan. Dang it! And so you say, all right, Mom, but you cry a little bit because you're a wuss. Anyways. Then your mom says, look, if you don't figure out how much of the cake is going to go in the pan, then we're going to ground you from the Xbox. And that makes you cry. Yeah, right?
PlayStation.
So you look at this thing and you want to tell your mom 2/5 because, well, you don't know what the heck you're doing. And then you realize, kind of like Isaac Newton did, that, well, if we can split this up into the same size pieces, then we're in good shape, right? So if I can take this half, and then I cut it this way into thirds. See, I've got this third, this piece, these three pieces. But how big are they in comparison to the pan? The pan now has been cut into sixths, and we have three pieces. Can you guys see that? Now on this other one, this third, we're going to cut this one in half, which leaves us with 6 pieces, but now we've got 2 of them. Well, you figured it out, and you say, Ma, I know what it is. Bam, 5/12. No, right? Yeah, it's 5/6. 5/6. You guys see the need to have common denominators up in count? Because if you don't, well, then you get grounded from the Xbox, and you have to weep. I don't know if they go over this in 6th grade. Frankly, I don't care because we're going to do it right now anyways. You guys may not have known this, or you may have, I don't know. But there's different kinds of numbers, as it turns out. And we're going to go over those different types of numbers right now. Let's go over the first one. They are called natural numbers. Now this symbol right here, to me, means number. To some of you guys, it means hashtag. In this class, we will not be using the hashtag symbol, but the number symbol, all right? That is a natural number. And what's great is that we have a symbol for it so that we don't have to write it all the time. This may come as a surprise, but the symbol for natural numbers is not just any n, though. That's a fancy n. It's very fancy, right? Yeah, right? Fancy, classy, however you want to say it. Natural numbers. Let's go and list those, okay? Now, unfortunately for you guys, we need to list all of them, okay? Let's start with the first one, 1. All right, now I'm going to do this slow so you guys can keep up, all right? The next one, 2.
No way.
It's pretty amazing, right? Yeah. Some people knew it, some people didn't. Whatever. Next number, bam, 3.
Mind blown.
Listen, we got a long ways to go, so don't get too, don't get too excited yet, because the next one, 4. Amazing.
I'm speechless.
You guys ready for the next one? Does anyone think they know what it is?
I think it's 5.
Bam, 6.
Oh.
I just got it.
Well, 6 the next one. What's the next one? Bam, 5. There you go. You see that? You see the, no, that was good. You see the space, that was, yeah, okay. You guys ready for more?
Yeah.
Too bad. It just goes on and on. How far up does it go?
Infinite.
To infinity.
And beyond.
Yeah, and beyond. Okay, that's great. Well, they're in there. They're just caught up in that 3 dots. Those 3 dots just means it goes on in that pattern forever. Does anyone know anyone that's ever counted to infinity before? Yeah, you do?
It was myself. It took me about 3 days.
Oh, wow, that's a long time. You're the second person I know that has. The only other person I know that has counted to infinity? Chuck Norris. Okay. You guys don't know who Chuck Norris is? All right, fine, whatever. All right, in any case, those are natural numbers. The next type are called whole numbers. Whole numbers. And this one may come as a surprise, but the symbol for this one, once again,
It's a fancy.
fancy W. See how fancy that is?
Oh wait.
I mean, you show that fancy W to people, man, and they're going to be like, oh, look how fancy this person is. We got to step our game up. All right, let's give you guys some of the whole numbers. Bam, 1, 2, 3, 4, and then it goes on forever.
Oh, that's annoying. That's the same thing.
It's the exact same thing. How awesome is that?
That's
Just one minor difference. 0.
You do.
There it is.
Of course.
Well, why is 0 in there?
Because it's a whole.
Yeah, because it looks like a hole, right?
Oh.
Yeah.
Oh. That's all.
Now, if you're not very familiar with these two types of numbers, that's okay. There's a program that comes on, and you can watch it on YouTube if you want, Sesame Street. Okay, they will help you with those. Now, they only go up so high, but they can help you. In fact, if you want to learn in a different language, I think they have those as well.
Dora?
I think I can go to
I don't know. No, I was talking about Sesame Street, but whatever. Okay. All right, so those are whole numbers. Let's move on now to one that may be a little less familiar, integers.
I heard that word before.
Integers are great. Oh yeah, I forgot. Let's show the symbol on this one. Once again, coming as a no surprise, it is a fancy I.
That's a Z. Fancy Z.
No, it is not a Z. It is a nice fancy I.
That is a fancy Z.
See, if you said it was a Z, then you're just not classy enough yet. You got to work on it. So you got to step your game up.
More classy.
So just get a little bit more classiness in your life, and bam, you'll be like, oh yeah, I got this I thing down. Integers are numbers such as 0, 1. That's not a 1. Now let's go back. 1, 2, 3, and so forth.
No, you would say you're going to fly.
How awesome is that? No, 5 is too much writing. It's hard. My hand's starting to cramp. Well, as it turns out, those ones are pretty much the same as the whole numbers. You guys see that right there?
All the exact same.
However, it also includes their opposites. -1, -2, -3. These ones should look familiar because, well, we've been using these a lot lately. Well, there's another type of number. They're called rational numbers.
I thought they were going to go with ice.
Rational numbers are, well, rational. And they do have their own symbol. Once again, it's a very classy R.
Need my monocle.
There it is.
That's a Q.
No, okay, see, there it goes again, right? Oh, I see a Q. Nope, it's an R. Fancy. Super fancy R. Classy R. In terms of classiness, it would destroy the classiness of all others' classiness. If you don't see that as an R,
I think maybe
well, you got to work on that, okay?
Wait, should I put an R or a Q?
That's an R right there. I drew an R.
I can see the R.
I wrote an R right there.
I see
If you guys think it's a Q, then, well, you may lose points.
I see it.
All right. All right. Rational numbers include, but are not limited to, actually they kind of are.
1 and 2.
Let's go and look at some of these. Let's look at these. There's different types of rational numbers, and they're all rational. And by the way, natural, whole, and integers are all rationals. Here's why. It has to be a number that can be written as a proper or improper fraction. Yeah. Proper or improper fraction. So we did talk about this. Who will tell us what a proper fraction is? Yes.
Where the numerator is smaller than the denominator.
That is correct. Very good. What is an improper fraction then? Yes.
Where the denominator is bigger than the numerator.
Correct. So those are improper and proper fractions. They need to be either integers or, well, yeah, they should just be integers. So what does this mean? Well, it means we got to take this up just a step further. And that leads us to decimals. Let's talk about repeating decimals. So a repeating decimal would be like, does someone have an example of that? Very common one is 0.3. That repeats though. So it would be a 3 that goes on forever. Hopefully you guys have seen this. That is what we call bar notation, which indicates that the 3 goes on forever. But we also have a very specific type of repeating decimal. Alright. So, with repeating decimals, there's a specific type of repeating decimal that we cover. Terminating decimals. So terminating decimals is kind of exactly how it sounds. At some point, some of the numbers get terminated. For example, here's a common one, 0.5. Well, terminating decimals are a very specific type of repeating decimal. What number is repeating on 0.5? Yes? Now that's what we would want to think, right? But the 5 doesn't have a bar over it, so it's not the 5. It's a 0. We can make that 0.50, which repeats forever. Bam. We just don't have to. So another one that we're used to, maybe 0.1. Some people like 0.25, right? Because we can convert those into fractions pretty easily. Alright. All of these are types of what they call real numbers. And yes, it has its own symbol as well. This one is a fancy R. Bam, super fancy. Well, the R for rational is, well, I would say that's more fancy. The one for real number is not as fancy, but it's still pretty classy, right? Now, some of you guys are thinking about this real number stuff. Well, why do we have to call these real numbers? Because there are such thing as not real numbers. Fortunately for you guys, you don't have to cover those until maybe 10th grade. There is one other type of real number. We don't deal with it too much. These are called irrationals. Irrational numbers have to do with decimals. And its symbol, super fancy, bam, irrational. Irrational numbers include numbers that have non-repeating or terminating decimals, such as pi. Has anyone never heard of pi before?
Oh yeah, I like pi.
Pie is good. Pie can be savory, but it can also be sweet. You can have a cherry pie, but you could also have a vegetable pie, right?
You can also have a number.
You could have a meat pie with bacon, right?
Oh yeah, gotta get.
I think those ones where they stuff the pizzas are kind of like a pie that's meat.
Stuffed crust.
Bam, I like those.
Chicken pie.
Well, there's also another one. Let me redo this. There's this irrational number called E. If you guys had a calculator, you'd be able to find both of these.
E is a number.
E is a number.
My life is a lie.
It was created by one extremely nerdy person, Euler. Euler's constant. Others include square root of 2. None of these we're going to deal with until maybe pi we'll deal with later on, but E and the square root of 2 you guys want to deal with until later. Let's look at something else that we should cover on this.
Are we ever going to use those symbols?
Yeah, so let's look at some examples of that. Right? So some examples, you guys give me a number.
6.
I heard 6 first. 6. And what will happen is the homework may say something like, what are the classifications of 6? How would you classify this number? Well, is it rational? Yes, because it has a decimal that repeats, but it's a repeating 0. Of course, we don't have to show that. So it is rational. And so again, we can write the symbol for rational. Is it an integer? Yep, so we need the fancy I. Is it whole? Yep. And is it natural? Yes, it is. Alright, you guys give me another number.
42.
9.42. 7. Alright, that works.
17.
Well, is this number natural? Nope. If it was natural, it would occur in nature, but this one doesn't. Is it whole? Nope. Is it an integer? Nah. Is it rational? Sure is. Right now, that number is terminating, a terminating decimal, but if we made it repeating, it still would be rational. Thanks for pointing that out. Now we got to go over the different types of numbers. Here are the different types of numbers that exist. Now, I don't think they talk about this in elementary, but we're in senior elementary, so it's kind of the same. The first type of number that we're going to go over are they occur highly in nature, so we call them natural numbers. And just so you guys know, this is not a hashtag, that's a number symbol. I'm going to call it a number so I don't have to write the actual word number. Natural number. Natural numbers have their own symbol as well, so that we don't have to write the words all the time. It is a fancy N. That's pretty good, right? Yes. All right, natural numbers. Start with the number 1. The next one is 2. I want you guys to think about this, all right? Okay? I'm going to take my time so that you guys understand that the next number is 3.
I'm lost. How did you get that? How did you get that? 1, 2,
Yeah.
3.
Okay. The next one, 4. Nailed it. Okay.
Is the next one 5?
The next number,
6.
5. Yeah. Hey, I know this, we discover new things every day. The next number, bam, 7. After 7 clearly comes 6. There we go. There we go. All right, then we got a symbol that means that this goes on and on forever. In the same pattern, how far up does this numbers go? To infinity. Now, counting to infinity is an extremely difficult task. I only know of one human that's been able to accomplish it.
I do.
Someone has counted to infinity.
That's not true.
Chuck Norris.
Oh yeah, Chuck Norris.
Chuck Norris. Not only did he count to infinity, he did it twice. Okay?
That's not true.
You guys, no, he did. He's Chuck Norris, man. All right. The next type of number we have are whole numbers. It is for Chuck. If you speak badly about Chuck, he may appear and roundhouse kick you in the face. Just so you know. All right, hold on. Let me finish. Whole numbers are represented by the symbol, and this may come as a surprise. Oh, that didn't work out very well. It's a W, but it's a fancy W. See that? It's like a classy W. So you guys gotta step up your classiness levels.
I'm pretty classy.
I hope so, because we'll find out here pretty soon. Let me talk about some whole numbers, like 1, 2, 3, and so forth. These are the whole numbers, all of them. 1, 2, and 3, and everything else. And 0. 0 is a whole number, but not a natural number because it doesn't occur in nature. Also, 0 is a whole number because, well, it kind of looks like a hole. All right, next up, integers. Integers are represented by the very classy and sensible I. Yep, that is a fancy I if I've ever seen one. A nice fancy I for everyone to remember. And the integers are numbers such as 0, 1, 2, 3, and so forth. Alright, those are all of the integers, except the ones I haven't listed, which are -1, -2, and so forth. So this one goes infinitely to the negatives as well as to the positives, and that's pretty cool. Next up, so you guys are going to have to order numbers, and part of that is knowing which one's greater and or not greater than, or some people say less than. So we use these symbols. This one's the less than symbol, because it kind of looks like an L, right? That's pretty sweet. And then we also have the greater than symbol, which goes this way because it kind of looks, like a G. So there's our greater than or less than. And of course, we also have the equals, and now it looks like two arrows pointing in opposite directions. But whatever. And so in elementary, they said something like, hey, let's give you guys a number like 17. And then they gave you another number like 81, okay. 81, right up and count. And you guys thought it was great because the teacher said, well, it's kind of like a mouth that's eating the 81. And if they got real creative like elementary teachers do, which is kind of weird to me. I like elementary teachers, don't get me wrong, just sometimes they're a little bit too happy. All right, so they draw some teeth on this thing right here, and they say, oh, see, it's a mouth. And if they got real ambitious, all right, they'd be like, oh, look, hey, this thing, bam, we're going to be real creative because we're in elementary school. And then they put some mouth on it like this, and then gave it some feet, and they gave it some feet, and then they gave it a tail like this, right? Bam, and then they gave it an eyeball.
There you go. That's amazing.
And then for some reason it was really mad. And they said, hey, look, see, it's an alligator, and alligators always eat the biggest thing. Which is kind of messed up, right? Because it's like, hey, just eat the fattest, biggest thing around. It's kind of offensive to fat people like me. But anyways, just so you guys know, I can't see any stinking alligators on your stinking sheets, okay? If I do, I'm going to have to dock points off, okay? No stinking alligators! This is now junior high, even though it's more like senior elementary.
This one's really bad.
No alligators. So here's the problem, though, is it's just an alligator, so we need to add some stuff to this guy to really make this all junior high-ish like, right? So I'm going to give him some wings up in here. There we go, right? And then we're going to give him another set of wing on the other side. It would be weird if he only had one wing. Bam, now he's got wings. Those aren't any wings, though. Those are bad wings. So now we have like a bat alligator looking thing, like a bat-a-gator, or an alligator bat, an alligat, I guess. But I better not say any of this kind of garbage either. It's not good enough. We need to add more. So let's go ahead and add a nice little shark fin on this guy. Give him some gills, like this up in here. Well, now we've got like a bat alligator shark. A balagark. Or maybe like an alligator shark bat. An alligator. No, that's not good. What about maybe like a shark alligator bat? Like a shaligat. There we go, the shaligat. See, now we've got a shaligat. Okay, see, this is acceptable. This is acceptable, okay? I don't want to see any garbage with this just a stinking alligator, all right? Now be careful. Well, we can, let's color up his teeth up in here. He just had some dinner. There we go. Anyways. No, it's not blood. It's his gums. I gotta warn you guys. They don't show these on Nature because no one's ever escaped from one. Here's the problem, right? If you see one on land, you can't really run from it because alligators are so stinking fast.
No, actually, I watched a documentary this morning, actually, and they can only run 10 miles per hour, and they get tired really
Which is still faster than you. All right, well, anyways, they're extremely fast. You can't really swim away because it's got that shark effect. And if somehow you can fly, well, they got some wings there. So
Mine's very
these have not been seen in nature without, you know.
Wait, but